Hello and welcome to checkpoint 4.12. They want us to use the definition of partial derivatives as a limit to calculate the partial of f with respect to x and the partial of f with respect to y with our given function. So we have a function up here, and these two formulas provide our definition, our limit definition for derivatives, partial derivatives. So let's do one of them. Let's do the first one, and this could get a little lengthy and full of algebra, but the partial of f with respect to x will be equal to the limit as h approaches 0. Now, wherever we see an x, we are going to replace it with x plus h. So we have a 4 x plus h, and then we'll take the quantity squared of that, plus 2, and we have x plus h times y, and we have a minus y squared, plus 3, and we have x plus h minus 2y plus 5, and that would account for this first part. This is all over h, and then maybe I'll put the minus down here, and then it's essentially the same function, 4x squared minus 2xy minus y squared plus 3x minus 2y plus 5, and that is also over h. Okay, so that's a little lengthy. We do need to expand this part over here, this first part with the f of x plus h, and that will entail, let's write it over here, let's keep the same color. This is going to be the limit as h approaches 0 of 4, and then this is going to FOIL out. And let's distribute the 4 while we're at it. So the first term is x squared, that'll be 4x squared. The middle term is going to be 2xh, and we'll multiply it times 4, so that's going to be 8xh. And the last term would be h squared, and we'll multiply that times 4. So that's that first part, and we'll distribute this. Well, there's the 2 and the y, so 2xy. And 2hy. We have just a regular y squared, and we have plus 3x plus 3h minus 2y plus 5. This is all over h. And then we're also subtracting still the 4x squared minus 2xy minus y squared plus 3x minus 2y plus 5 all over h. Okay, now if we focus on this line over here, which is actually one line, we can see that there's going to be some terms that are going to be matching with a negative, like this one and this one. They would cancel out. When we have a 2xy and a 2xy, we have a y squared, negative, a positive 3x, and a negative 2y, and a 5. So all those disappear, and then we have the limit as h approaches 0 of what's left up here is 8xh plus 4h squared plus 2hy plus 3h, and that's it, divided by h. Now everything in the numerator, if you can see, has an h in it. So we'll take the h out, and this would be, and that would cancel with the h in the bottom, and we would have left 8x plus 4h plus 2y plus 3 with the h is taken away. And then if we let h approach 0, we'll see that this is the only term that has an h in it, and that's going to go to 0. And what we have left will be 8x plus 2y plus 3. Okay, so that's a derivative of f with respect to x. A derivative of f with respect to y would be done similarly, except you would replace the y's with x plus h or y plus h, and then you'll see things cancel. Essentially, this whole f of x, y would cancel with things in here, much like this whole term with f of x, y canceled, and then you'll get the factor out in h, and then let h approach 0. Okay, so we won't do that for this checkpoint, but you can see the rest of how the rest of this works in the PDF version of the checkpoint. Okay, I hope that helps.